Hello everyone, my name is Zackary Newman, here with STREAMWORKS to talk to you guys about how to program and set up your Raspberry Pi for use within Robot Drone League. So your first step is going to be to go to raspberrypi.com/software and download the imager, and then go ahead and use it, like shown on screen, to select the Raspberry Pi OS and then your SD card and go ahead and write it so that way you have your SD card. Once it's done, you just boot up into the Raspberry Pi. You're going to have to go through a setup process, which I've sped up for you, where you just want to choose language, keyboard, a few other things, and then you're going to have to connect it to Wi-Fi. It will fail when it gets to it to sync the clock, but that's fine. We can deal with that later. There it is. It's trying to update. You can see it does not sync the clock, which is fine. So the first thing we want to do is actually go to our config menu, and we want to set up I2C, which is going to be under the interfaces tab. And what I2C will do is it'll let us talk to the servo bonnet we have put on the Raspberry Pi. So you just want to enable that, and you should be good to go. First, we're going to go ahead and set the date. So this actually fixed all of our timing issues that we had earlier. So next, we have to install all of our Python packages. So you can see the commands on screen. So we just need the servo kit and Pygame. Currently, we're just doing 2.0.1. If there's a newer version by the time this comes out, you can go ahead and try that. Now we're just going to open up our Python editor, and I'm going to walk you through the code. So our first step is we're going to import our libraries. So Pygame and the servo kit. We're actually going to be using from to get our servo kit class from the servo kit library. Anyway, first we're going to create that kit from the servo kit. And what this kit is essentially our bonnet, like I said, that we put on the Pi. So it's actually a 16-channel bonnet, so you have to specify that in the code. Next just involves the basic Pygame setup, so we have to initialize it, and then we want to initialize the joystick part of it specifically, because we're going to be using joystick to read from our controller. Python, or Pygame specifically, calls them joysticks rather than controllers. I know typically when you think of a joystick, you think of just like the one single thumbstick. But in this case, joystick is the whole controller. But you can see down here, I'm actually calling it controller because I prefer to think of it that way. And you can actually name it whatever you'd like. So we're actually you can see we're creating a controller from the joystick, and we're using joystick 0. So if you had multiple joysticks, it's just counting up starting from 0. So if you had a second controller for, your arm on your robot, you could do joystick 1. And then we have to initialize the controller. So next up, we're doing the loops. This is actually what's going to be running as you're driving your robot around. First step is to pump the event loop, which essentially just refreshes what we're getting from the controller, so we get the most updated data. And then we're essentially limiting it to 60 frames a second, so it's not running too fast. And you can actually probably get away with lowering it a lot more than that. You can see it's using the clock we created earlier. So now we're going to go ahead and get the axis. That's what it actually calls the little thumbsticks. And we're going to get the axes from our controllers. We're going to get axis 0 and 1 for now. We will actually have to change those later to what we actually want to drive it with. And you guys can actually customize that to drive your robot however you'd like. Now, this next line here is a little bit confusing, but this essentially eliminates some of the drift issues that you might have, where if you're not holding it, your robot might, slowly drive forward. This will go ahead and fix that. So you're going to be changing the minimum and maximum pulse. You can actually see it's continuous servo 0, which is actually those numbers are referencing the channels on your servo bonnet. So you'll actually have to look at the bonnet and figure out what channel you plugged it into. And here's where we're setting the pulse. We're setting it to 1,100, and then the maximum to 2,000. As soon as we're done with that, we can actually go ahead and just copy and paste the line. Because we have to do this again for our other one, because we're using 2 of the channels. And in this case, I'm just going to call it channel 1. You can see we're actually using the 0. You can see I'm swapping it for 1 twice. So the 2 have to match front and back. But as long as they match, you should be good to go. And now we're just going to set the throttle of each one. So we're going to start by setting the throttle of servo 0. And we're going to assign this to one of our axes. So we're going to assign this one to axis 1. And then we just need to do the same thing again for axis 2, which shouldn't take too long. And as soon as you're done with that, you've essentially completed the code. Like I said, there's a few small tweaks that need to be made, but this is the basics that you can run from. The next thing that you're probably going to want to change, actually, we'll save it first. It's always good practice. The next thing you're going to want to change, actually, is those bonnet numbers. So in my case, I've actually got mine plugged into 3 and 0. I just use 0 and 1 just for demonstration purposes, but you can obviously change those as needed. And now we're actually going to try out some different axis values. So I'm essentially just trying different ones in those places. You can see I'm trying 1 and 2 at the moment. We're seeing if that gets us anywhere. And you kind of have to figure it out as far as how you want to control it. So I'm pushing random buttons on the joystick, seeing what happens. I think in the end I ended up going with 1 and 4. Yes, I did. And if you want to drive yours the same way I did, you should also just be able to use 1 and 4. There we go. 1 and 4 are set up and ready to go. And we should now be able to drive our robot. And we run the code. So you can see now we're actually using the joystick. And as I push the buttons, you can see the wheels on either side spin, just like we want them to. Perfect. So now that our code is working, we can go ahead and we can make it so it runs on start. At the moment, you saw we had to hit the run button there to run our code, which works fine, but it's a bit cumbersome to have to plug your setup into your robot into a monitor every time you want to run the code. So we're going to edit the rc.local file within the etc folder, and you can see we're essentially adding the command for running our code. And the rc.local file runs when you turn on the Raspberry Pi, so it'll run your code when you turn on the Pi. You can see the command right there on screen. Save it, and go ahead and reboot the Pi. And you should see, right there, I've frozen it on this screen. It ran into an error when it was starting up because it couldn't find the servo kit. When this first happened, it confused me for a moment, but then I kind of realized what was happening. You can actually see here a few different commands that I tried out, but what I'm trying now is essentially, we're just saying, okay, maybe it didn't install correctly. I'm trying essentially just a slightly different way of reinstalling it, or just of installing it. This is a functionally identical to what we did earlier, but I just wanted to see it. It's always good to test. I kind of wanted to show some of the process in the video. So you can see I tried some different things, and we've settled on adding sudo. So what essentially happened is we installed the package for essentially the user account, but not on the Pi as a whole. So doing sudo before our install command should fix that. And then we can do the same here with Pygame as soon as it's done with this, which it now is. And we can just adjust this to say Pygame. There we go. We're downloading it. And we're good to go. Now when we reboot the Pi, as soon as I turn it on, you can see we can immediately drive it around the floor with no issues, no monitor needing to be plugged in. I hope you guys enjoyed, and I hope your robot is working well. This should give you somewhere to start. I thank you all for watching, and I hope you have a nice day.